Good day, everyone. Today we will continue with our second new pair of angles created. It's still parallel lines, chapter 4, lesson 2. Now in this chapter, we will explore the relationship between pairs of alternate angles, our new angles, that are created when two parallel lines are cut by a third line, and by now we know that the name of that line is our transversal. Now the second type of angles that are formed when a transversal cut parallel lines are alternate angles, right? They are alternate angles. Now you get alternate interior angles and alternate exterior angles. Now we have these two parallel lines, and this area in between the parallel lines, they are called the interior angles. And of course, outside the parallel lines, 1, 2, 7, and 8, they are the exterior angles. So we get alternate angles on both sides of the transversal, and both of them must be interior, right? This side and that side, on opposite sides of the transversal. We know it can't be 3 and 4 because they are supplementary adjacent angles. So we find our alternate angles on opposite sides of the transversal in between parallel lines. Now we call them the alternate interior angles. 3 and 6 form a pair of alternate interior angles. 4 and 5 form a pair of alternate interior angles. They can also be on the outside of parallel lines. Then we call them alternate exterior angles. Look here, over here. Here we have the parallel lines. There's at the transversal over there, one side of the transversal, and then on the opposite side of the transversal, but both of them must be exterior. They are never adjacent. They are not adjacent. As you can see, they are not adjacent. So in between parallel lines, on opposite sides of the transversal, they are not adjacent, and both must be interior. Or on the outside of parallel lines, on opposite sides of the transversal, one on the left hand side, one on the right hand side, and both exterior angles. If we color the lines that make the alternate angles, we will see the Z shape. Here the green, right? I see a Z. So you can look for angles forming the Z shape. There, there, and there. Both interior on the opposite side of the transversal. This side, that side. Over here, green, that's the Z upside down. Look there. One on top and one below the transversal. Never next to each other, because then they are supplementary adjacent angles opposite each other, right? And we call them alternate interior angles. Now, below the two angles, or here below, we have two angles that are outside the parallel lines. Look here, over there and over there. So we call them alternate exterior angles. Alternate exterior angles. Right. Then we get our alternate interior angles. This one and that one. Or that one and that one over there. So practice makes perfect. See if you can recognize the pairs of alternate angles in the following diagrams. Using the numbers in the following diagrams, give 4 pairs of alternate angles. I will give you 1 pair and you can figure out the other 3. 1 and 8. Both exterior on opposite sides of the transversal. Right? You can write down the other 3 pairs for me. Next one, B. Write down 1 pair of alternate angles. Here we have the 2 lines. Here we have the transversal. Over here, opposite sides, one this side, one that side, and it will be 3 and 1. 1 pair of alternate angles. So we have that line and that line there. We have a transversal there and one over there. Right? Can you figure this one out? Yes. Below, you see here, and on the opposite side over here. Both interior. In between these 2 lines. 2 and 4. Right. D. Which angle is alternate to angle 8? 8. It is over here. So we must look for the partner. 8 and, can you see? 8 and 3. In this case, in this instance, this is the transversal now. That is the 2 lines. Exterior angles, right? Exterior. So it will be 8 and 3. Write down an angle that is alternate to 4. 4 is over there. This one you can see. This is the 2 lines. This part is the interior part. So it will be 4 and 1. Yes. Which angle is alternate to angle 5? 5. This is the line. That is the line. In between these 2 lines, 5 on the one side, 1 on the other side. So it will be 5 and 1. Remember, answers on the last slide. For that reason, I will not write it in here. Angle 2. In between the 2 lines, 2 on the one side and 7 on the other side. So, angle 7 is alternate to angle 2. Or 2 is alternate to angle 7. 3. Look here, 3. Exterior, outside, on the outside of this line. So we must look for another one outside of the line. So it can be 3 and 8. It can also be 3 and 9. That's right. Next one. Which angle is alternate to angle 8? Over here, 8. And you can see the answer in between these 2 lines, opposite sides of this transversal, 8 and 9. Which angle is corresponding to angle 3? Now we get back to our previous lesson. You remember the rules? Both of them will be on the same side of the transversal, right? And it will be 3 and 8. Positions the same, one above the line and the other one above the line. Corresponding angles. If angle 3 here is equal to 55, write down the sizes of angle 8. 3 and 8. Do they form a pair? Yes. They are corresponding angles. Okay, but I'm actually saying, yeah, 3 and 8, they are corresponding angles. So we know if angle 3 is 55, 8 must be 55. And 2, what is the size of 2? If 3 is equal to 55, what is the size of 2? 3 and 2, did they form a pair? Yes. Supplementary adjacent angles. To get 2, you must deduct 55 from 180. Then 9. So 9 form a pair with a given angle. The given angle is angle 3 because I told you over here angle 3 is equal to 55. So if angle 3 is equal to 55, it is the given angle. What is the size of 9? 9 is vertically opposite angle 3, so 9 must be also equal to 55. Which angle is alternate to angle 1? Alternate. Here we have the line, and there we have the other parallel line. Watch. 1 and you see the Z? Outside, outside. 1 and 5. They are alternate exterior angles. Angle 6. This one is easy. Right, that's our Z symbol. Line, our transversal. Opposite sides of the transversal, 6 and 4. We are going to use our previous knowledge now to find out if alternate angles are equal or equal to 180 or even equal to 90 when a transversal cuts parallel lines. Example, you must use your knowledge of vertically opposite angles, corresponding angles, supplementary adjacent angles on straight line, and then you must write down the values for me from angle 8 to from angle 1 to angle 8. But we are not going to measure angles. We are going to use our previous knowledge to work out the values of all the angles. Okay, I'll take my pen out. Just a second. The pen. Angle 1 you can see is equal to 50. What is the size of angle 2? Here we have a pair of corresponding angles and we know they are equal. So I'll write it in. Angle 2 is also equal to 50 degrees because it is corresponding to the given angle 50. What is the size of 3? Now we know that 2 plus 3 is equal to 180 because we have a common vertex and they are next to each other. So if angle 2 is equal to 50, angle 3 must be equal to 180 minus 50, and that will give us 130 degrees. What is the size of angle 4? Vertically opposite angle 2. So it must be 50 degrees too. 5 is vertically opposite angle 3. You see there? So 5 is equal to 130. Then we have 6. 6 is vertically opposite the given angle. So 6 is also equal to 50 degrees. 7 and 5, they are corresponding angles. 7 and 3, they are alternate angles. So 7 and 50 and 7, they are supplementary adjacent angles. So from there we can see that angle 7 can only be equal to 130 degrees. Reasons again, supplementary adjacent angles, this two, or corresponding angles. Right. Write down the pairs of alternate angles and their sizes. So I'll write down one pair. I'll write down angle 1. And the alternate pair, the other one is 4. Angle 4. Right. Angle 1 is alternate to angle 4. They are the exterior alternate angles. Angle 1 is equal to 50 degrees. Angle 4, where's angle 4? Over there, is also equal to 50 degrees. Okay, we take another one. I'll take a pair of interior alternate angles. I'm going to take 8 and 5. Angle 8 and angle 5. Angle 8 is 130 because it is vertically opposite angle 7. So angle 8, the size of angle 8, 130. You see there? The size of angle 5 over here, also 130. Now on your own you can do the other two for me, but I notice already that when the lines are parallel, the alternate angles are equal. Look there. Angle 1 is 50 degrees, angle 4 is 50 degrees, so they are equal. Angle 8, 130 degrees, angle 5, 130 degrees, equal. Okay, so a pair of alternate angles, they are also equal when the lines are parallel, just like the corresponding angles. So we can now conclude that when two parallel lines are cut by a transversal, any pair of alternate exterior or interior angles are equal. Right. Now we are going to find the unknown angles or unknown angle. Now we use the same method as in lesson 1, right? As before, to calculate unknown angles, we first identify the pairs of angles that we know and how they are related to the given angle. So we have our given angle over here, right? And we ask, is angle Y or 65 degrees and angle Y, do they form a pair? Yes. 65 degrees and Z, do they form a pair? Yes. 65 degrees and X, do they form a pair? Yes. So you can actually start with any of these three angles marked with the letters, with any one. I will start with Y. So Y is equal to 65 degrees. Reason? Vertically opposite angles. Y is vertically opposite the given angle. X. Yes, X. I can see 65 degrees and X, they are alternate angles. So X must be equal to 65 also. So we write it in here. X is equal to 65 degrees, alternate angles. It's also corresponding with Y, but we only need one reason, right? So it's also corresponding there with Y. Then lastly, Z here. Now, if we take these two angles, the given one and Z, they are on the same side of the line, below the line. They have a common vertex, and we know they add up to 180. So, Z plus 65 is equal to 180 degrees, angles on a straight line. Z is equal to 180 minus 65, and Z is equal to 115 degrees. So there we have the steps to find the unknown angles. So we have exercise 2. Remember, answers on the last slide. I will just help you. Calculate the angles indicated by A, B, C and X, Y, Z. This is our given angle. So the given angle form a pair with which other angle? Right, you can see 48 and A form a pair. They are, you see the Z? Alternate interior angles. Right, so we know that alternate interior angles, they are equal. 65 and B, do they form a pair? Yes, they are also alternate interior angles. So B must be 65. Then C, do we have a common vertex? We have 3 angles, 3 adjacent angles on this straight line. 48 and C, they are adjacent. C and 65, they are adjacent. Common vertex, and we know to get C, we must subtract 48 and 65 from 180. We look at this one here. You see, this line and that line, they are the parallel lines. Then we have 2 given angles, 45 and 68. You must decide 68 and which other angle form a pair, C, B or A. Right, and you can see on the right hand side of the parallel line, on the right hand side of the parallel line, this pair of angles, they are corresponding angles, which mean they are equal. So A is exactly the same size as 68. A is equal to 68. Why? Because they are corresponding. If you can't see it, from the parallel line to the transversal, from the parallel line to the transversal, a pair of corresponding angles. Now 45 degrees. It forms a pair with C, B or A. You see the Z? Right. Here we have it, Z. 2 parallel lines, transversal there. So 45 and B, they are alternate angles, they alternate interior angles, they in between these 2 lines. One on the one side, one on the opposite side. So B and 40, B is equal to 45 degrees, alternate interior angles. So we have A and we have B. Now we must get to C. And watch here, C, B and A, they form a straight line with a common vertex. So this 3 must be equal to 180. So you must subtract A and B from 180 to get to C. Next one. Oops, I see a straight line. I see a common vertex. So the only way to get to A is to subtract 48 and 45 from 180. Right? Once you have the size, now you must look at B. Is B vertically opposite A? Remember, vertically opposite angles when 2 lines intersect. So B is from the transversal to the parallel line. You see there? the vertically opposite angle pair will be also from the transversal to the parallel line. So from the transversal, you see there? So B is vertically, this line, vertically opposite. Let me just show you again. This line and that line intersect. So B is vertically opposite A and 48. That's the only clue I'm giving you. B is vertically opposite A and 48. So, once you have A, you can find the value of B. B is vertically opposite A plus 48. If X is equal to 30, there, 30 degrees, and Y is equal to 70 degrees, find ACM. You must find this angle there. You will have to add a line parallel to PQ through C, and we call that line FC. I don't have a ruler, so I'll just try and rule a line as straight as possible. So you will rule a line from there to there, and you will call this line FC. FC. And this line is also parallel to PQ. You will have to add a line parallel. Now this sign this sign is actually to tell you the line is parallel, right? Two lines like that means parallel. So you will have to add a line parallel to PQ through C, line FC. So we have something like that. Remember, you must find the value of ACM, which is this angle here, from there to there. And that is the only clue I'm going to give you. You can figure that one out. Find CHT. CHT. CHT, so it's this angle. Okay. You have a straight line here. So X and 100 will be equal to 180. And remember, two angles mark the same. They have the same size. So you must decide, is X alternate to this angle, or is X plus X alternate to that angle? Remember, from the parallel line to the transversal, from the parallel line to the transversal, they are the alternate interior angles. This page or this slide, we have all the answers. So you can start all over again, work it through exercise 1, exercise 2, and then you compare your answers with my answers. If you're not happy, you start all over again and you practice, because practice makes perfect. Thank you so much.